The coolest, most interesting numbers in math, it shows up everywhere, even when you don't think it's relevant. But what is pi? We've all heard about it, but what is it? If you take any size circle and you take its diameter, it will fit around the circumference of the circle 3.14159265358979323846264338329750228 times and a little bit, because pi never ends. It is an endless number that never repeats itself, which is why it's called irrational in math. How can such an important number in math be so infinitely irrational? Well, what is a circle? A square has 4 points, an octagon has 8, a dodecagon has 12 or whatever. A circle is defined by having infinite points equidistant from the center. If a circle by definition has infinite sides, it kind of makes sense that the ratio has infinite decimal points. And there's other numbers like this in math that show up everywhere. They're really fundamental numbers to our universe. Pi, there's e, which is 2.71 something, and that's fundamental for logarithmics. There's I, which is the square root of -1, which is also called an imaginary number because you can't have a square root of a negative. Oop, I always do this. I gotta turn around. There we go. These numbers show up all over math, and they're so important, but they're irrational. Now, what really trips me out is they all fit together perfectly. It's actually haunting how well these seemingly unrelated irrational numbers fit together. They fit together in the most beautiful equation ever discovered by humans, which is Euler's identity. E to the I pi minus 1 equals 0, or plus 1, doesn't matter. You've got E, I, pi, 1 and 0, perfectly balanced in one identity. Pi is for circles, E is for logarithms, I isn't even a real number. It's literally called an imaginary number, and the only reason we accept it in math is because the math behind electricity wouldn't work unless we accept the fact that the square root of -1 is a number.